main thing about a combination is that the order does not matter. And we learned earlier today about formula, its permutations with the order divided out. Take out this little line. Whenever I write that NR in brackets, it's like, I'm so tempted to write a fraction. It's like hard not to write one number below another number and not think of writing a fraction line in between. And we have some special cases. And choose N. You go to the prize table, or your English teacher says, we've got choice this semester. You have to read 3 books. You can choose from this list of 3. 3 choose 3 is all of your choices that are possible. Well, there's only one way to do that. You'd be like, thanks for all the choice. So N choose N is 1. We saw that like 52 choose 1 would be 52. We've seen some of these things before. What's really interesting with some of these is that if you look at the formula on the formula sheet, N choose N would look like this. What is the other number?
N minus N.
N minus N, which would be?
0.
0. And remember how 0 factorial is equal to 1? Again, that becomes important in this situation.
Now you cancel out the N factorial. 1 over 1.
1 over 1. Perfect. And we saw how 10 choose 6 was equal to 10 choose 4 today. And it's, again, the formula is really easy. I actually like writing the 6 first and then the 4 second. It really doesn't matter. And we get to some fun kind of questions. Poker is a game where you get 5 cards. It doesn't matter. When they give you the 5 cards, you get to like rearrange them. Like if you got 9, 10, Jack, Queen, King, you're like, oh, too bad they didn't give them to me in the right order. I guess I don't have a straight. I should fold. No, that would be a bad idea. So how many poker hands are there? Well, if you take 52 cards and you choose 5 of them, you get the number of poker hands that are total. So we go 52, choose 5, 2.598. Almost 2.6 million different poker hands. I'm going to show you guys something you'll probably never ever see again in your life. You take 1, 2, 3, 4, 5 cards. Are you ready for this? I got the King of Clubs, the Queen of Hearts, the Queen of Spades. This is actually pretty good. Usually this sucks. I got 3 queens and a jack. It's like they weren't shuffled, but I pulled them.
3 of a kind.
This is pretty good. Usually when I do this in class, it like just really sucks, and I'm like, you should be amazed. But I think you should actually be amazed, because your chances of seeing this exact hand are 1 in 2.6 million. Of course, this is true with every single hand you get in poker. It's just another 1 out of the 2.6 million.
Yeah, I'd be more impressed if it was a 4 of a kind. Sorry.
Well, I'm sorry.
Better luck next time.
Usually I get all 5 different cards. Is usually what happens to me.
Did you get all 5 different cards earlier?
I got a pair, so I was pretty excited that I usually don't get the. And they were in a row. Not that that matters.
It would have also been impressive if you got a full house.
There was so much room for impressiveness.
But no dice.
So this is how many poker hands are possible. And tomorrow we'll look a little bit more in depth, and we'll be actually able to figure out why some hands in poker beat other hands. I mean, the obvious thing is intuition says one is better than the other, right? But there are some hands in poker that make you wonder, why is that one better than something else? Like my 3 of a kind, if you had 2 aces and 2 kings, my 3 queens is considered better. But it took 4 of your cards to make yours and only 3 of mine. So maybe yours should be better. Who decided, right? This is one of the things that you might have wondered, like, who decided which of those ones should be better? Did they just play it a long time and start to feel like, oh, this happens less than this? Or did they actually figure out the mathematics behind it? And we'll see why the 3 of a kind is better than 2 pairs. And that's true of any poker hand. And we can figure out the probabilities and the chances of getting each one.
So we'll figure out why a straight flush is the best hand possible hand.
We can figure that.
Best royal straight flush.
Well, that's actually really, like, a royal flush is really easy to count. Out of the 2.6 million, how many are there? 4. There's 1 in spades, 1 in diamonds, 1 in clubs, and 1 in hearts. And there's only 4 of them possible, which makes them super rare.
And that's why they're the best.
Okay. Committee of 2 boys and 3 girls is to be selected from a class of 15 boys and 8 girls. How many ways can this be done? So again, this is a decisions with combinations question. You have to decide boys and girls. How many choices do you have for boys? Does the order matter? No. So it'll be 15, choose 2. How many choices for girls? Order matter? No. 8, choose 3. And then add or multiply in between. Because this is where your brain starts to play tricks on you to be like, well, I add when it's cases. Should this be an adding? Well, I multiply when it was spaces before. Should stay multiplying? Because it's spaces, because it's decisions, it will be a multiply. For cases, and we're going to have cases with combinations as well. But for cases, you have to count the whole thing for it to count that you have to add. And right now, after the first space, 15 choose 2, do I have a full committee of 5 people after that? No, I've just got the boys part. So it's not a full committee, that's why it's multiplying in between. And of course, we could multiply this out and figure everything. This is where the other class got up to. Do you want to catch up to them? Or do you want to be behind?
Be the underdog behind.
We'll
catch up tomorrow.
We can catch up
Keep
tomorrow.
going.
Keep going.
I say we can catch up
keep
tomorrow.
going. Relax. You have extra time tomorrow.
So, we get even further ahead.
We don't need to be even further ahead.
But we have to tell, to make that matter, you'll have to tell them that you're ahead of them, to assert dominance.